Hi everyone, this is Taylor Hokinson, and today we're going to talk about some of the most basic aspects of Photoshop. So to start the demo today, I've downloaded an image from the internet. For our purposes, really any image will do. This one's called explosion.jpg. One basic thing you should know about the way that computers remember digital images is that first you have the title and then a dot, and the material that follows the dot is called the extension. So in this case, the extension is .jpg or JPEG. You can also see the spelled .jpeg. That tells the computer the way in which the image was compressed, and therefore it knows more about how to handle it. Now to open this up in Photoshop, there's a number of ways to do it. If I already have Photoshop installed down here on my dock, we're all working on the Macintosh operating system, I can just drag the little icon down to Photoshop and open Photoshop that way. And we'll twiddle our thumbs while this opens. Okay, so here we have explosion.jpg. Now some of you will have used Photoshop before. For some people this will be the first time you've ever opened it. And especially for you guys, it's probably a little intimidating. There's lots and lots of options all over the screen, so don't worry about any of that yet. We're not actually going to use a tool in this particular lecture. We're just going to assess the video without changing it. Okay, to do that, I'm going to go up to Image up here in the menu, and then go to the drop down for image size. And here I get this window that's very important, and we're going to go through this a couple times to make sure everyone's got it. Okay, up here at the top we've got pixel dimensions. Down here we have document size, and then we have a couple of different options that we can check or uncheck. Now when it comes to the quality of an image, especially a digital image, there's a lot of confusion out there, and I see this in my intro classes every year. A lot of students by default assume that resolution, which we've all heard before, an image's resolution has to do with the quality of the image. And in fact this is not true. So let's take a look at why this is confusing and why this piece of information is so important. Up here at the top I have pixel dimensions, and pixel dimensions will tell me the first of the two most important things about a digital image, which is that the number of pixels that make up the image are 1081 in number in width and 864 high. Now to get the total number of pixels that make up this image, I would multiply these two numbers together because they're laid out on a grid, and I'd get some total number of pixels. That'll tell me the pixel dimensions, or how many pixels make up the image. Now down here below we have document size, which is kind of confusing because a portion of document size has to do with print size and a portion does not. So here we've got resolution that we talked about before, and we see it's 72 pixels per inch. It is most likely that if you download something from the internet, 72 dpi is the way it's going to come down. Sometimes you'll see 96, which was sort of a weird resolution Microsoft instituted for a little while. That's kind of gone out of fashion. And then, of course, you can see basically any other resolution, but another common one is 300 dpi, which is good in the printing environment. So more on that in a bit. 72 dpi, very common. That means if we're going to display an image in the on-screen environment, say on a projector or a monitor or something like that, a bunch of experts came together and decided that if you have 72 pixels in an inch, that looks pretty good on the screen. It's not a very scientific designation. Now if you print something out for a variety of reasons, your eyes are much better at assessing the quality of an actual physical print, and 72 dpi no longer cuts it. In that case, we generally bump up to 300 dpi, again as a standard, not necessarily as anything scientific. All that we care about here is fooling the eye, making the eye feel like it's gotten what it's looking for. So on-screen environment 72, and print environment 300 plus, depending on the capabilities of your printer. Okay, so if up here we have pixel dimensions, which tells me the number of pixels in the file, then resolution means the size of the pixels in the file. Think about it. If my resolution is 72 pixels per inch, that means as I count across the space of an inch, I can fit 72 pixels. Therefore, that means that a pixel, assuming that they're all the same size, of course, has to be 1/72 of an inch across in order for 72 of them to fit in an inch. It's really simple when you think about it, although this one trips a lot of people up. So whenever you see resolution, just remember this doesn't necessarily mean image quality. It's talking about how many pixels can fit in an inch or some other unit of measure. Therefore, it's talking about the size of the pixels. So pixel dimensions is the number, and resolution is the size of the pixels. Now if we look up here at document size, we can see that if we were to print this out of a physical printer, a commercial photographic printer, the image would come through at a width of about 15 inches and a height of about 12 inches. Okay, so a relatively big print. But we can also see that the resolution is 72, which means that even though it looks pretty good on my screen, it's not going to look very good once I print things out in the real world. So let's talk about how to modify these different settings so that we can change our documents around for the on-screen and print environments. Okay. So like we said, 300 looks good when printing. If I type in 300 here, watch very closely what happens. Now my resolution is 300, which means that I can fit far more pixels within an inch, and those pixels are smaller. The print dimensions have stayed the same. So if I can fit more pixels in an inch, and the print dimensions have stayed the same, then necessarily the computer has to invent a larger number of pixels to make up for the gaps that I've created. Okay, so I've got a much greater number of pixels. My resolution is now something that'll look pretty good in the print environment, and I can print out my image. However, keep in mind that we started with a finite data set. So if I hit undo, I can send this back and see that originally I had about 1,000 by about 850 pixels. Multiply those together, that gives you a certain number, and resolution and so forth. Now by making this 300, and because I have the resample image checked, what I've now done is cause the computer to invent a set of pixels. And in fact, this image would have more invented pixels in it than original pixels. And you know, modern computers are very good at this operation. The image would probably still look pretty good. However, it's going to come across as a little bit mushy in the print environment. So again, I'm going to hit undo. Let's see what we can do with the original data set without inventing any new data. And to do that, I'm going to uncheck resample image. Now when I uncheck that selection, a couple of important things happen. First of all, I lose access to the ability to modify this upper box. And if you recall, that means I can no longer modify the number of pixels that make up our image. So that is fixed. However, down here I can still modify resolution, but now you can see that the resolution is chained, or its modification is tied to these other two variables. So width, height, and resolution are all going to be dependent on one another when resampling is unchecked. In this case, if I type in 300 for my resolution, now you can see that my document size has gone down. And the reason for that is I'm taking the same number of pixels, I can't change the number, I'm making those pixels smaller, right? By increasing the resolution, I'm saying more pixels need to fit in an inch, and therefore their size is smaller. So smaller pixels, same number of pixels, necessarily yields a smaller image. Now if I were to print this out of a printer, I'd get a better result. It would be a relatively small image, only about 3.5 by 3 inches. However, that might be able to work for your particular application. So moving forward, we're not going to start from the web picture. The web picture is usually the smallest compressed version of an image that you might have. Generally, you're going to start from this big honking file that you produce on a nice digital camera, and then you'll have a lot of options in terms of how to save it. There's a benefit, of course, to having the image have a smaller footprint for the computer, so it just takes up less space. So we'll take a look at a lot of different compression methods in terms of reducing that file size without necessarily reducing the visual quality of the image. But the most basic manipulation that you're looking at is this interplay between the number of pixels and the size of the pixels that make up an image. So let me hit cancel, and let's go through this set one more time. So open an image in Photoshop, image, image size. Okay, by default, when this pops up, we can see pixel dimensions is equal to the number of pixels that make up an image. Document size tells me the width and the height of the image if I were to print it out right now. And resolution tells me the size of the pixels. 72 is a very common size for things viewed in the on-screen environment. Scale styles, that's something that you don't have to worry about, just leave that checked. Constrain proportions, you're usually going to have checked. That means if you change the width, you want the height to change in kind. You don't want to squash your picture. So the only one that you really are worried about is resample image. When resample image is unchecked, I can no longer affect the number of pixels that make up the image. All I can change is the pixel size, and as resolution goes up, pixel size goes down, right? So 300 dpi means that more pixels can fit in an inch when compared to 72, and that necessarily gives me a smaller image as well. With resample checked, I'll hit undo. Now I have access to changing all of these different features, which means I can change the number of pixels and the document size and the resolution and so forth. In this case, when I make the resolution 300, I'm asking the computer to invent new pixels, right? Because I'm making the pixels smaller, but I still have the same overall area to fill. Therefore, the computer invents more based on these different compression schemes down here, which we won't really get into in this intro class. Now this also works in the opposite direction. Say I made the resolution 1, which means that only 1 pixel fits in an inch. It's actually a 1 by 1 inch square. In that case, it's only 15 pixels across to make up the entire image. Okay, so that's the basic of image sizing. We'll talk about that more in class in person when we all meet.